In this video, we'll be looking into NECO 2025 likely chemistry questions and answer. Possible questions that you can add up to whatever you are reading. So question number 1 says that you should name this compound. Now let's look at this compound. Okay, let me write solution here. So how can I name this compound? Now the first thing is to look for the parent chain. Let's look for the longest chain. Okay, 1, 2, 3, 4, 5. So my parent chain is 5. Okay, no, it can. Let me count from here. 1, 2, 3, 4, 5. Okay, it's still 5. So if I should go from here, 1, 2, 3, 4, 5. So my parent chain is what? Is 5. And then it has a functional group of what? Alcohol. So that means it's going to be pentanol. Pentanol. So if it's pentanol, then what are the substituents I can see here now? That is 1, 2, 3, 4, 5. So this happens to be the substituent, also a substituent in this place. So if I'm counting from the carbon atom, carrying the functional group, which is OH, from here, so that's going to be 1, 2. So that means the functional group is on carbon what? Carbon 2. So that will be what? 2 pentanol. Okay, or you call it pentuol. Okay, so now I have the name as 1, 2, 3, 4, 5. That's a 2 pentanol or pentuol. Now the substituent. This will be my carbon 1. This is my carbon 2, my carbon 3, carbon 4, and carbon 5. So counting again, I'll have it as 1, 2, 3, 4. That will be 3, 4 dimethyl 2 pentanol or 3, 4 dimethyl pentuol. So that will be 3, 4 dimethyl 2 pentanol, or you call it 3, 4 dimethyl pentuol. I'm supposed to join this place together. Let me write it here again. 3, 4 dimethyl pentuol. So that is the name of this particular structure. Okay, now let's move to question number 2. Question number 2 here says that we should calculate the volume of what? The volume of 0.25 mole per dm cube solution of H2SO4 that will contain a mass of 3.5 gram of the acid. Okay, so the solution here is going to be, formula is sorry, they say calculate the volume of 0.25 mole. Okay, solution of this contain. Okay, so the solution is going to be, you can write concentration, or you write solubility, any one of the two. So let me write concentration in mole per dm cube equals to mass over molar mass times 1000 over volume in cm cube, or probably use this formula N equals to CV, any one of the two, so whereby your N is what? Mass over molar mass. You remember molar mass, which is equals to your this thing, mass over molar mass, your okay, let me show this book here. So whereby your concentration is this C times your volume in dm cube, volume in what? Dm cube. So you can use this formula, or you can use this formula. So using this formula now, our mass is what? Our mass is what? Our mass is 3.5 gram over molar mass of H2SO4. Remember that H is 1, plus sulfur is 32, plus oxygen is what? 16. So equals to concentration is what? 0.25 times, you don't know volume. So we can do this arithmetic. Okay, let me continue the arithmetic here. So this will now be equals to, from here I have what? I have 3.5. I have 3.5 gram over calculating the molar mass of this guy now. Let me use calculator. So that will be 2 plus, that will be 2 plus 32 plus 16 times 4 should be, okay, 16 times 4 plus, that is 64 plus 32 plus 2, and that is 98. So the molar mass for this guy here is 98. So here is now 98 gram per mole equals to 0.25 times V. Is that not okay? That is 0. What? 0.225 times what? Times V. So from here now I can now do the mathematical arithmetic by saying 3.5 divided by 3.5 divided by 98. Okay, so that will be equals to 0.0357 equals to 0.25 V, and finally V is going to be 0.0357 over 0.25. Okay, so if I do that, okay, so that will be equals to 0.14 dm cube, 0.14 dm cube. And if you want to convert it to cm cube, so you can say converting it to cm cube, that will be 1000 times 0.14, and that will be equals to 142.9 cm cube. So that is the answer for that. Now for question number 3. Question number 3 is this. So how do we go about this question number 3? Let me go to the solution. So the solution is it will be mole equals to mass over what? Over molar mass, whereby the mass is what? 25 gram. The molar mass, magnesium should be 39. Sorry, magnesium is 24, so that will be 24 plus carbon is 12 plus 16 times 3, so that will give us 25 gram all over. Okay, I said magnesium is 24. Okay, so 24 here, so then that will be 16 times 3, 16 times 3, that's 48 plus 12 plus 24, so that will be equals to 84. So 84 gram per mole. So having this, then you now say 25 divided by what? 84, and that is giving us 0.2976. So that will be giving us 0.29 approximately 298, 0.298 mole. So that is the answer to that one. Okay, now for question 4. Now look at the question 4. The question 4 here, you can read it very well. Give 2 examples of, let me write solution here. So now give 2 examples of strong electrolyte and weak electrolyte. Now strong electrolyte, you see, strong electrolyte, let me just give you one hint. Strong electrolyte, they are all strong acid, strong base, and some salts. Strong electrolyte, they are what? All strong acid, all strong base, and some particular salts. So such as strong electrolyte, so such as strong acid HCl, in aqueous state, HCl, HNO3 in aqueous state, and also H2SO4 in aqueous state. You can see here I predicted we should mention 2, but now I'm even giving you 3. Sodium hydroxide is also a what? In aqueous state, is also a what? A strong electrolyte. Okay, which other one again? Potassium hydroxide in aqueous state is also a strong electrolyte, and so on. Sodium chloride too is a salt, is also a strong electrolyte in aqueous state or molten state. In aqueous state or what? Or molten state. Now what about weak electrolytes? Weak electrolytes. So weak electrolytes are basically all weak acid and all weak base, such as what? Ethanoic acid, CH3, COOH in aqueous states. So ethanoic acid, such as ammonia. Ammonia is a weak base. Ammonia in aqueous state. So ammonia is a weak base. It does not mean this one should be in aqueous though. So ammonia is a weak base. So even water too. So water too is also a weak electrolyte. So and so on. Now, to continuation, now say also, look at the question. Also, copper 2 salt was electrolyzed using, this one is a calculation question. Let me write a solution 1 and let me write a solution 2. Solution 2. So looking at the solution 2 now, the solution 2 now says that copper 2 plus salt, copper 2 salt rather, was electrolyzed when 0.5 ampere, that is current. Current is 0.5 ampere and 9650 coulomb of electricity. So quantity of electricity is 9650 coulomb. Then passing through the solution of the salt, calculate the mass. We have to look for mass is unknown. Mass of copper deposited and the time taken and T. So it's a two different question. The mass and the time taken. Now let's look at that. Which formula are you going to use? Mass equals to I have a formula which is a I times T times molar mass over N times F. Yes, I have this formula like this. I have this formula like this. Sometimes this N can be written as Q. So what does now look at this formula. Remember that this IT is the same thing as Q. Q equals to IT now, you remember. So Q equals to IT. Yeah. So this IT is same thing as Q times capital letter M. This M means molar mass. So all over this small letter Q is the quantity of charge, and that is what 2 plus. And this F is the Faraday. So now let's go. So if we are now solving this, we already have our key. I'm looking for mass. Small letter M. This is small letter M. Small letter M. That's mass. This one is capital letter M. That is what? Molar mass. So now let's continue. I have my Q here should be 9650 coulomb times my molar mass is 63. Molar mass of copper 63. 63 over my Q is 2 from this charge plus 2. So I'll write 2 times my Faraday is 96500. So now let's do the arithmetic. If 0 cancels 0 here, so my mass will be equals to 965 times 63 over 2 times 9650. So let me do the calculation here. 965 times 63, that's equals to 60795 all over 9650 times 2, and that is what? 19300. 19300. So if I divide the both, that will give me 60795 divided by what? That 19300, and that will give me 3.15. That is 3.15 gram. So the answer is 3.15. Although there's alternative method though. There's alternative method to use. You understand? But okay. But let me assume I've done this mass. Now for the let me leave this I. Now for the I'm asked to look for the time in what? In seconds. For me to look for the time, the only thing I can use is to use my Q equals to what? I times T. I already know my Q should be what? sorry, 9650. So that would now be 9650 equals to, my I is what? 0.5 times T. So by the time I divide, my T will be equals to 96550 all over 0.5. So if I do that division, then I will be getting 9650 divided by 0.5, and that will be 19,300 seconds. 19,300 seconds. So that will be my answer. Now I've done that, but alternatively, let me use another method to solve this question number 1. So alternative method is that alternative method. So looking at alternative method is now, from here Q equals to IT bar. Okay, so I already know that my Q, so I don't need to go through this stress of using this I. You understand? My Q is 9650 coulomb, right? And I know that 1 Faraday equals to 96500 coulomb. So how many Faraday will give me 9650 coulomb? So by the time I do the arithmetic, my x will be equals to, by the time I cross multiply, you sure you get, my x will be equals to okay, let me cross multiply. That would be okay, that would be 9650 over 96500. Do you get? So here we have, I want to look at the unit though. Okay, here we have the coulomb, here we have coulomb and Faraday together. If you cross multiply this thing very well, I've jumped a step. If you multiply this, do you get? Okay, so if this coulomb cancel coulomb, so I am left with, let me divide this, 9650 divided by 96500. So that will give me 0.1 Faraday. You can also practice this thing as well, oh, please, because I'm a calculator, so practice it as well. So now after having this out from the charges is +2, right? So the charges is giving us that 2 Faraday equals to 1 mole. How did I get this 2? I got this 2 Faraday from the charges, because the charges is +2. So this, what the charges is +2, what I wrote here is from the second law of electrolysis, the second law of Faraday. So that's why this one came up like this. 2 Faraday, because of the charges is +2, Cu2 plus, do you get? That's why I wrote 2 Faraday here. So 2 Faraday equals to what? 1 mole. So how many mole will this particular Faraday give me? 0.1 Faraday will give me, let me use y mole, let me use y here. If I cross multiply, my y will be equals to 0.1 Faraday mole all over 2 Faraday. If Faraday cancel Faraday, therefore my answer is going to be 0.05 mole. 0.05 mole. So I've gotten the mole, and now I can now get the mass from where number of mole equals to mass over molar mass. So whereby the mass, is equals multiply, the mass will now be what? Mass equals to number of mole times what? Times molar mass. So whereby number of mole is what? 0.05. Molar mass is 63. So by the time you do this, then you are going to get, so your mass will be equals to 3.15 gram. So that is the answer to this. Now look at the alternative A, and then look at the alternative B method of solving this particular question. But I would advise you that you should use this alternative B to answer your question. Do you get? So please give us a like, share this video to help other students, add this up to whatever you are reading. At least these are the area of specialization, like the area of concentration where WAEC, NECO, even NAPTEP, most of all these A-level exams used to set. They used to touch organic chemistry. They touch this stoichiometry, measuring volumes, and then this one too is still under calculation of mole. They used to touch from SS1 textbook, and this one is electrolysis. So they set questions on this electrolysis as well. So share this video to your friend, give us a like, and give us a nice comment, and please subscribe to our YouTube channel. Also, give us a super thanks if you have the money. Join our membership platform, and I wish you best of luck in your exam. Bye.